So we are given these three parametric equations, and we are to draw the graph and mark the orientation. Now, the first one, you can solve this, or you can turn this into a non-parametric version by solving for t. So here, if you subtract 3 and divide by 4, you get this equal to t, right? And in this case, if you subtract 1 and divide it by -1, then you get t. So since these two are both equal to t, I end up with this equation where now t is gone. And from here, I actually know what the equation should be just by cross multiplying. So it's -x plus 3 equals to 4 times y minus 4. And then add 4, so -x plus 7 equals to 4y, and then dividing by 4 again. That gives you y equals to -1/4 x plus 7 over 4. Now that's not so hard to draw. I know that the y-intercept is 7 over 4, which is like, if this is 1 and this is 2, 7 over 4 would be slightly less than 2. So I guess this is 7 over 4. And then for the slope, you just have to know that slope is rise over run. So if you go down 1, then you go 1, 2, 3, 4, that's your next stop, and you connect those 2 points as a straight line. So this is supposed to be a straight line. It's hard to draw a straight line with the electric pen, but you get this. And now the only thing that you have to figure out is what's the direction. I have to mark the orientation. Which direction does this line go? And an easy way to figure that out is by differentiating this. So if you differentiate it, then x prime y prime becomes 4 comma -1, right? So you get a vector that's 4 to the right and 1 down. So that's your vector. This is your vector, and this is the direction vector of this line. So I know that the direction would be going this way. Okay, that's a little hard to see. Let me draw it better. Okay, so using the derivative, you can decide on the orientation. Alright, how about B and C? These are a little more tricky because it's hard to solve for t because of these cosine and sines. In that case, what you want to do is you want to make use of cosine squared t plus sine squared of t equals to 1. Okay, this t could be 2t in the case of C. So if you see cosine and sine, try to use this. There are some other cases. If you have like a tangent, you would use 1 plus tangent squared t equals to secant squared. So that could be another use. So if you have a curve where you see tangent and secant, that could be another possible thing to use. But anyways, here we just have sine and cosine, and your goal is to make this, which means you want to solve each one of these for cosine and sine. So I'm going to take x equals to 4 cosine t and divide by 4 so that you get x over 4 is equal to cosine t. And you have y equals to 3 sine t. Divide by 3 to get y over 3 equals to sine t. Then we plug these into this formula. Remember, cosine squared t really means cosine t squared, and sine squared t really means sine t squared. So if you plug in x over 4 here and y over 3 here, this equation now becomes x over 4 squared plus y over 3 squared equal to 1. Okay, so now we have gotten rid of the t's and we only have x and y. All that remains is to figure out what this curve is. What is this curve? Well, first you have to start with x squared plus y squared equal to 1, which everyone knows that it's a unit circle. And then you have to think about what happens if you replace x by x over 2. No, x over 4. See, replacing x by x over some number actually expands. So it's like taking this drawing, assume that this circle is drawn on a rubber band, and you're stretching this picture to left and right to make it expand, so that now you have 4 and negative 4, and this side is still 1 and negative 1, and you get this new circle. It's elongated in the x direction. Okay? And then finally, if you replace y by y over 3, then you do the same thing, but this time in the y direction. You stretch it in three times the original. So the end result is that you get a bigger circle-like thingy where it's not perfect, but what I mean is that these are 4 and negative 4, and here it's 3 and negative 3. So that's the ellipse. So that's the graph of B, except you still have to figure out the you have to figure out the orientation. And how do you do that? Again, you can find the derivative and see what that gives you. So x prime, before that, think about where this curve starts. When you plug in 0 and 0, cosine 0 is 1, sine 0 is 0. So when t is 0, this curve is at 4, 0, which is this point right here. Okay. Now let's figure out the derivative, x prime 0 and y prime 0. Well, this vector would be negative 4 sine t and 3 cosine t with t equals to 0 plugged in, which is 0 because sine of 0 is 0, but 3 for the y coordinate. So 0, 3 is a vector that's going up, right? Which means at this point the curve is trying to go this way. Right? Therefore, the orientation, the circle is going counterclockwise. So that's what we choose. So the direction is actually going that way. Just because the velocity vector at 4 is going up, it must mean that the circle is going counterclockwise. So I might say orientation is counterclockwise. Okay, part C, same idea here. I still want to use the fact that cosine squared theta, I'll just write it this way, cosine theta squared plus sine theta squared equals to 1. And to use this, I take each of these equations and solve for cosine and then sine. So divide by 4, I get x over 4 equals to cosine 2t. Second equation, y equals to negative 4 sine 2t. I plug it in as y over negative 4 equals to sine 2t. Then, because I can set theta as 2t, I can replace cosine 2t and sine 2t by x over 4 and y over negative 4. Okay, so here's what I mean. First, rewrite this as cosine 2t squared plus sine 2t squared equal to 1. This is true because the above equation is true for all angle theta, so I can have this. And then I use the fact that cosine 2t is x over 4 and sine 2t is y over negative 4, and replace each by x's and y's appropriately. And note that if you square a negative, it's plus. So the end result is that I have now you can draw this in two different ways. You can do what we just did for the part B. You stretch it 4 times in the x direction and stretch it 4 times in the y direction, in which case you're going to get a circle of radius 4. Or another way to figure that out would be really multiply 4 squared both sides and write it as x squared plus y squared equals to 4 squared, and indeed this is the circle equation with r being 4. So we know either way is this one, right? Also, at t equal to 0, x is 4 and y is 0. So you're at 4, 0, right? So at 4, 0, this curve starts. And again, the question is, does it go counterclockwise or clockwise? To figure that out, you want to know x prime of 0, comma y prime of 0, this velocity vector. And the velocity vector, the derivative gives you the velocity, right? The velocity vector is, if you differentiate cosine 2t, that's negative 2 sine 2t, so it's negative 8 sine 2t. And differentiating sine gives you cosine, so you get negative 8 cosine 2t. The numbers 4 become double to 8 because of the chain rule. Then you plug in t equals to 0, which gives you sine of 0 is 0. Cosine 0 is 1, so you get negative 8, which is a vector that's pointing downwards because you have negative in the y direction, x is 0, so it's a vector pointing downwards, which means that the velocity vector at 0 is pointing downwards, which means that it must be rotating clockwise. So the curve must be rotating this way. The orientation is clockwise.